need your help. My brother is applying to college and he keeps going back and forth between EE and ECE. And honestly, I don't even know what the difference is.
Well, EE and ECE. Okay, before I answer that, let me tell you about the job interview question first. I think it's relevant to your brother's applications.
Okay.
Okay, so Elon Musk, when he interviews people for pretty much any role, he asks almost everyone the same thing. Tell him about the hardest problem you've ever solved and walk him through that step by step in detail. Does that sound scary?
That sounds pretty normal.
Yeah, but it could also be the trap because anyone can describe a problem in broad strokes. But when being asked, okay, then what did you actually do? Further questions like that, many people would run out of things to say. And for those who actually did it, they usually have more details to share.
Okay, I'm intrigued, but I still don't see the connection.
Hold on that thought, you will at the end of this. Okay, let's start with the basics. So this is actually one of the most confusing things about engineering, even at universities that follow North American systems, is that they don't have a single standard name for this field. Some call it electrical engineering, some ECE, some mechatronics. It really depends on the school and what they focus on.
Oh, so is it just a naming thing or are they actually different?
Well, there's an actual difference. Think of electricity as water.
Water.
So EE is a reservoir, the pipes, the pump station, everything basically about how electricity gets made and moves around. Power grids, transformers, renewable energy, big voltage, big scale.
Okay, so EE is like the whole city's plumbing system?
Yeah, exactly. Electronics is more like the precision valve inside your faucet. They are tiny components, lower power, and super precise. Chips, sensors, communication system, those kind of stuff.
Oh, so electronics is the small stuff.
Yes, and the ECE acts as a bridge between the two. So it's where hardware meets software. And, modern computer at the end of the day is just a very sophisticated electrical circuit that happens to run code on it.
Okay, so if I'm getting this right, EE is more like the big picture, how power moves around, and ECE is more like the small stuff plus the code that controls it.
Yeah, it's a bit complicated, but that's exactly it.
Oh, okay, that actually makes sense. So how do schools even organize this?
In a lot of North American universities, you don't have to decide on day one. You come in as EE or ECE, and through your coursework, research, internships, you figure out you are more into the power systems, chips, or embedded software, which is actually great if you're the type of person who is curious about a lot of things, like your brother sounds like.
Oh, so what can someone actually do with this?
Well, let me give you an example. So there's this well-known engineer in China named Peng Zhi Hui, but you may not have heard of it. But he's also a very popular tech creator online known as Hui Jun. A few years ago, he built a self-driving bicycle on his own in his spare time.
Oh, a bicycle that drives itself?
Yeah, the bike balanced on its own, navigated obstacles, and mapped its own environment. I think the reason why it is so impressive is that to build it, he had to use everything at once. Motor control, sensors, embedded software, computer vision, and even mechanical design. Basically, the entire EE and ECE combined into one project.
Oh, that's insane. So that's what you can do with this degree?
Well, here's the interesting part. He didn't even study EE or ECE. His undergrad was biomedical engineering, which does touch some electronics and computing, but he went way deeper enough that he switched into communications engineering in grad school.
Wait, so he's not even from this field?
No, not on paper. but he ended up more versatile across hardware and software than most people who have majored in it. So EE and ECE can teach you stuff like this, but clearly you don't need the degree if you're driven enough like him.
Oh, okay. So then, remember that Musk interview question from the start?
Yeah, that's exactly where I was going. If someone asked this guy, Zhi Hui the question like, walk me through the hardest problem you hit on this bike, he could probably talk for hours. And that's the real difference between describing a problem in broad strokes and having actually lived inside it.
Okay, but if that's the difference, where do people who've actually lived inside it end up working, like in a real job?
Okay, that's really a great question. So I pulled up a real job listing. It's Tesla hiring in China right now. And it's describing exactly what we just talked about.
Oh, an actual job posting?
Yeah.
What's it for?
It's for their body control firmware team. Sounds like HR speak, but here's what it really means. You know how on a Tesla, the seats adjust themselves to your memory setting when you get in? Yeah, and the wiper know it's raining outside and turn on?
Yeah.
So that's this team. They make little things work, like wipers, mirrors, seats, doors. So using chips, sensors, and code, telling everything when and how to move.
Oh, so that's the hardware-software bridge thing from earlier.
Yeah, exactly. The posting literally says they want someone who can do hands-on hardware, bring up system debugging, and deliver high-quality C code on real-time embedded environment. To simplify that, it's just hardware and code.
Okay, what does real-time even mean?
Real-time means that the code can be slow. When you press a button, the door opens. There would be no loading spinner, no lag. And that's exactly what real-time embedded means. The software actually kind of glued to a physical thing.
Okay, got it.
Mm-hmm. And here's the part I love. Look at what degrees they accept. Mechatronics, electrical engineering, computer science, computer engineering, or anything equivalent. Does that sound familiar to you?
Yeah, that's basically what you said at the very start. Universities don't have one fixed name for this field, and now Tesla's posting is basically saying any of this or equivalent.
They are not drawing a hard line. They just want someone who can move between hardware and software.
Okay, is anything else in there?
Yeah, and one more thing is, after listing all these degrees, it says they also accept candidates with experiences that can show evidence of exceptional abilities.
Evidence of exceptional ability. That phrasing sounds familiar.
That's exactly Elon Musk's hiring philosophy boiled down to 4 words. And he talked before about how a degree matters next to him. What actually matters is whether you can show that you did the hard thing and how you did it.
Okay. So, knowing all of this, what do I actually tell my brother?
Well, just ask your brother 2 things. First, does he like working with the big systems, like energy, power, and how electricity moves at scale? Or the small stuff, like chips and sensors? If it's the small stuff, does he just want to build the hardware? Or does he also want to write code that actually runs on it? Big system is EE. Small stuff plus code is ECE. Small stuff without the code needs more straight electronics.
Okay.
Yeah.
But once he's actually picked a track, how does he even know which school is good for that?
That's a whole new video we will talk about next time.
Okay, deal. Send him this one for now.
Okay, wish him good luck and maybe warn him that math is no joke.